Hello folks, this video covers chapter 7 section 5, which is going to be our last section for this chapter, which is on how to solve trig equations. Now, side notes, to solve any equation, right, like 3x plus 10 is equal to 127. The goal is to isolate the variable, right? It's to use inverse operations to say, okay, we're going to subtract 10 from both sides, so that 3x is equal to 117, etc., divide both sides by 3, and, isolate x to get your answer. Well, the goal is still the same in trig equations. We want to go ahead and isolate our variable, but even before we can isolate the variable, we also want to isolate the trig function. So in other words, your trig functions almost act as a variable themselves, aside from theta. Okay, and sometimes there's more than one trig function. That's why I say isolate trig function or functions. Determine which angle or angles, sometimes there's more than one answer, is equal to that measure. And this is the extent of our notes. I'm really going to do more examples with you than we are going to talk about discussing, the ins and outs of it, because the reality is you've solved many equations before in your math career. We're now just going to do some that have trig values in it as well. Okay, so our first example, I want you to solve 2 minus 2 tangent theta is equal to 3 minus tangent theta. So again, the goal is to isolate your trig function. So in addition to isolating your variable. So the variable here is technically theta, but we want to isolate the trig function first, and I'll kind of explain to you why. And we can use inverse operations. Now, things to note, you cannot subtract 2 minus 2 is equal to 0 here. Tangent acts as a variable. So this kind of statement is almost the same thing as writing 2 minus 2x. You wouldn't dare subtract 2 minus 2 there, right? Because those are considered not like terms. Okay, but what we can do is inverse operations. So I can go ahead and say, okay, well, let's subtract 3 from both sides. And then 2 minus 3 is negative 1. Bring down negative 2 tangent theta is equal to negative tangent theta. Make sure you keep track of your negatives. So I've taken care of all of the constants. So let me try to get all the tangents to one side. So let me add 2 tangent theta to both sides. On the left-hand side, I'm left with negative 1 is equal to, on the right-hand side, negative tangent theta plus 2 tangent theta. It's just a positive 1 tangent theta. Now, you don't want to go ahead, so we could technically solve for theta, right? We know that the inverse of tangent is literally tangent inverse, so then we could say theta is tangent inverse of negative 1. But the problem with using your calculator is that your calculator is only going to give you one answer. We need all of the answers possible between 0 and 360 degrees. Okay, so for the sake of this entire page and in the future of trig equations, our answer for theta is going to be between 0 degrees and 360 degrees. Okay, so you're going to ask yourself, looking at your unit circle, or recalling what you know about your unit circle, where is tangent of theta, or what angles have a tangent value of negative 1? Things to remember about tangent. Tangent is found by dividing y over x, and you can also think about it as the slope. So hopefully that helps kind of trigger some maybe visions of where these angles should be. It also needs to be a negative 1, not a positive 1. So as you're looking at your unit circle, hopefully you see that we would have a negative 1 value, or a negative slope of at the angles 135 degrees and 315 degrees. Okay, second example. I want you to solve negative 6 plus square root of 3 over 2 minus 3 times sine theta is equal to negative 3 minus 2 sine theta. Okay, so this looks a little bit more complicated, but it's actually not so bad. Let's go ahead and leave this crazy number here to the left side alone for a second. Let's go ahead and take care of the sine values. So you can add either one, it really doesn't matter. I'm going to start with my most negative one, and I'm going to add 3 sine theta to both sides. And it's going to leave me with negative 6 plus square root of 3 all over 2. I canceled out my sine theta value is equal to negative 3. Negative 2 plus 3 sine theta is a positive. Oh wait, that's not times. Don't forget about your operations. You don't just want to leave your operations out in the dust. Okay, so this should be negative 3 plus 1 sine theta. And I guess I technically don't need that 1 there. Okay, so my sine theta is almost isolated. And from here, we can go ahead and do a few things. If you look at your number on the left, if you recall just properties of fractions, we can't simplify all of this. Negative 6 and the square root of 3 are not common terms. But if they're both being divided by 2, then I can split up that fraction to be negative 6 over 2 plus the square root of 3 over 2 is equal to negative 3 plus sine theta. Okay, and what that's going to do is, then if I go ahead and add 3 to both sides, on the right-hand side, obviously it cancels. If I add 3 to the left side, well, negative 6 over 2 is negative 3. So then negative 3 plus 3 also cancels, leaving us on the left side with the square root of 3 over 2 equals sine theta. So you successfully isolated your trig function, and you want to figure out what value or values of theta make this true. Well, things to remember, your sine is a y value. So looking at your unit circle, I want to know where is my y value square root of 3 over 2. The other thing to know is that it's also positive. So since it's positive, my answer should be in quadrants 1 and 2. That's where I have positive y values. So if I'm looking in the first and second quadrants, I'm going to see that if theta is 60 degrees and 120 degrees, then the y coordinates at those points are the square root of 3 over 2. A third example, negative 8 minus the square root of 2 all over 4 minus cosine theta is equal to negative 2 minus 5/4 cosine theta. So again, we have another one of those weird stacked fractions. This time we're dealing with cosine. There's a fraction on the right-hand side as well, but it's a lot simpler. And so, of course, you can do a few different things. You can break up this fraction over here on the left if you'd like. I'm going to do a couple of different steps in one. So I'm going to go ahead and say, let me add cosine to both sides. So if I add 1 cosine theta on the left side, it cancels. If I add it to the right side, you could obviously use your calculator, but negative 5/4 plus 1, well, another way to write 1 is 4/4. So negative 5/4 plus 4/4 is equal to negative 1/4 cosine theta. And then I have minus 2 equals, then I have negative 8 minus square root of 2 all over 4. So I'll lie, I'm not going to do 2 steps in one. I'm going to slow down. So all I did there was add cosine of theta to both sides. And then we can use the same tactic as we did on the last problem. I can go ahead and split up the fraction on the left side. Again, there's a monomial on the bottom. We're only allowed to do this because it's both the numbers on top are being divided by the same number. Again, you cannot split this up, side notes, if it were opposite. So if I had 4 over negative 8 minus square root of 2, this is not the same thing as 4 over negative 8 plus 4 over negative square root of 2, okay? This is not mathematically correct. But since the monomial is in the denominator, then we can write negative 8 over 4 minus square root of 2 over 4. On the right-hand side, negative 2 minus 1/4 cosine theta. We can't combine those because this negative 1/4 is attached to cosine. But what we can do from here is I can take care of my constants, so I can add 2 to this side. And then if I add it to the left side, and I recognize that negative 8 divided by 4 is negative 2, then negative 2 plus 2 will make that term cancel. Okay, leaving me with negative square root of 2 over 4 is equal to negative 1/4 cosine theta. So I'm almost there. Remember, the goal is to isolate cosine theta. So since it's being multiplied by negative 1 over 4, you can divide both sides by negative 1 over 4, or dividing by a fraction is the same thing as multiplying by the reciprocal. So I could multiply everything by negative 4. And then if I do that, it's going to cancel this negative 1/4 because 4 is in the denominator. And then on the left-hand side, I'm going to have negative 4 times negative square root of 2 over 4. And again, negative times a negative is a positive. A 4 on the top and on the bottom is a 1. So it's only going to leave me when I distribute it to the left-hand side with the square root of 2 is equal to the cosine of theta. So I've successfully isolated my trig function. Cosine of theta is equal to the square root of 2. So if you look at your unit circle and you try to figure out, okay, where is cosine theta square root of 2? Well, remember that cosine is going to be your x-coordinates. It's positive, so we have positive x-coordinates in the first and the fourth quadrants. Now, as you look on your unit circle, you might go, none of the x values that I see are square root of 2. And even though there are many of other angles other than the typical like 30, 45, 60, 0, 90, those angles, the issue is that you will never see a cosine value of square root of 2. I want you to think about why that is. Why is that? So if you're looking at your unit circle, the four corners are 1, 0, 0, 1, negative 1, 0, 0, negative 1. Again, I'm focused in on just the first and fourth quadrants. Why will I never have a cosine value of the square root of 2? Well, if you approximate the square root of 2, you're going to get about like 1.41 or so. So if the square root of 2 is about 1.41, hopefully you realize I will never have an x value bigger than bigger than 1, because that's where the unit circle stops, is at 1. So there will never be anything bigger than that. So in this case, you got to be careful. There's actually no solution. There is no angle that will ever have an x value bigger than 1, so the square root of 2 is not a solution. Okay, 2 more examples. Number 4 is the square root of 3 times tangent theta plus tangent theta is equal to negative 2 tangent theta sine theta plus tangent theta. So at first you're like, oh man, this question's a lot longer than the other one. This is great. She always does the easy examples and then gives us hard examples and things get more complicated. Yes, to an extent, but hopefully not as bad as some of the other things that we've done that got really, really challenging. Even though this question's longer, it's not going to be as bad. And the other thing to recognize is that there are 2 trig values, or 2 trig functions rather. So let's go ahead and write this. Typically greater than 2, or greater than or equal to 2, I guess. So 2 or more trig functions, 2 or more trig functions implies factoring. So instead of just like solving your trig value to equal 0 because you have 2 trig functions, there's no way that you're going to get each one equal to 0 without factoring. So anytime you see more than 1 trig value, you need to go ahead and factor. Now, you could factor off the bat, or you can factor after you rearrange some things. And I'm going to go ahead and factor off the bat. This is not my recommended path of algebra for you, but I'm going to show you kind of what happens if we factor right away. Okay, so first thing to notice is that tangent is in everything. So if I factor out a tangent on the left-hand side, I get tangent of theta. The only thing I have left is the square root of 3. Plus, there is no other term here, but it technically has a coefficient of 1. And then if I factor tangent on the right side as well, then I get tangent of theta is negative 2 sine theta plus, again, just 1. Well, you may say, okay, well, both sides are being multiplied by tangent. So if I go ahead and just divide both sides by the tangent of theta, then my tangent of theta cancels. And that's lovely. And then things look simple and I can keep moving on. Well, the deal is you cannot cancel a trig function. Okay, cannot cancel. And I say that in parentheses because, you know, we're basically making it disappear. You cannot cancel a trig function. So that's the danger of doing the algebra this way. So what's going to happen is you just need to ask yourself, basically, what does tangent of theta need to equal in order for original equation to be true? What does tangent of theta need to equal in order for the original equation to be true? So if you find yourself doing algebra, maybe you factored too early and you cancel something out. If you go back to the original equation, there might be an obvious answer. So if I look at my original equation, I've got square root of 3 times tangent of theta plus 1 times tangent of theta equals square root of 2 times tangent theta sine theta plus tangent of theta. Well, notice if they all have tangent of theta, if the tangent of theta were 0, so if tangent of theta were 0, then everything would be true, because 0 plus 0 does indeed equal 0 plus 0. Okay, so in canceling out tangent, I want to account for that it's 0 here. Now, I'm not dividing by 0, right? I just did some algebra here, so there is no division by 0 in the original equation. It would just be adding a bunch of zeros. So the thing to remember is that tangent is y over x, or it is slope. So if you're looking at your unit circle, I want to know where is the slope equal to 0. Well, the thing to remember is that slope, if we do y over x, is equal to 0 when we have a horizontal line. Okay, so this is when you have slopes equal to 0. So in this case, theta would be 0 degrees and 180 degrees. Okay, so that takes care of the tangent. Now, let's look at what's left in that problem. So on the left side, we have square root of 3 plus 1. On the right-hand side, we have negative 2 sine theta plus, what the heck was this over here? Okay, up here should have been 1. Did I write another plus sign? I don't even know what that is. Okay, so that should just be 1. Negative 2 sine theta plus 1. So down here would be negative 2 sine theta plus 1. So now if I'm trying to get sine alone, I'm going to continue with some algebra. Subtract 1 from both sides. Leave me with the square root of 3 equals negative 2 sine theta. So since it's being multiplied by negative 2, I'm going to go ahead and divide both sides by negative 2. And I get sine theta equals negative square root of 3 over 2. Things to note, we remember that sine is the y-coordinate. The other thing to note is that it is negative. Y values are negative in the third and fourth quadrants. So what angles in the third and the fourth quadrants give me y values of negative square root of 3 over 2? Well, that will be where theta is equal to 240 degrees and 300 degrees. So this answer actually contains 4 angles. Theta could be 0, 180 degrees, 240 degrees, and 300 degrees. Last example. Similar to that one, it's going to involve some factoring again. 3 cosine theta is equal to negative cosine theta tangent theta plus 2 cosine theta. So this example, I'm going to take the approach of, I recognize that I have 2 trig functions. I have cosine and tangent. And anytime you see that you have 2 or more, that's going to imply that we're going to factor. Factoring, if you think back to algebra, typically implies that we want to go ahead and get things set equal to 0 first before we factor. You don't have to, but if you cancel things out, then you kind of have to go through the mess that we did in the last problem. Okay, so the tip here is that factoring also usually implies getting everything set equal to 0 before you factor. So everything equal to 0 first. So let's do that. Let's take everything on our right-hand side and move it to the left. Or you could do vice versa, but I just see some negatives on the right, so I know that they'll be positive if I bring them on the left. So I've got 3 times the cosine of theta. On the right-hand side, negative cosine theta times tangent theta will change to a positive cosine theta tangent theta. And then plus 2 cosine theta will change to a negative 2 cosine theta, all equal to 0. So then what happens is if I get it equal to 0 and then I factor, I notice all of 3 of these terms have a cosine value. So then I have a cosine of tangent. If I factor that out, I'm left with 3 plus I'm left with tangent in the middle term. And then I'm left with negative 2 in the third term equals 0. And then I could also go ahead and combine my like terms in this parenthesis. So cosine theta times 3 minus 2 is 1 plus tangent theta equals 0. And then hopefully this looks similar to like algebra days of I have something times something else equals 0, which implies that either of these equal to 0 would make this true. Okay, so at this point you would split it up. And we would say, okay, well, either cosine theta could equal 0, or 1 plus tangent theta could equal 0. And then again, you're going to use your unit circle to help you figure this out. Cosine is an x value. So where are your x values equal to 0? Using your unit circle, well, that's going to be where theta is equal to 90 degrees and 270 degrees. And something we haven't talked about quite yet is, checking the validity of your answers. So we know in algebra, some of like the telltale, oh no, that can't be an answer scenarios is when you end up dividing by 0, right? So like if we end up factoring something and you end up with 2 answers, if you quickly plug one of those answers back in, let's say you have x over x minus 2 plus 3x over x minus 5 is equal to blah, 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 blah. If you end up with either 2 or 5 as an answer algebraically, right, everything you do may be true, you cannot use those as final answers because when you plug them back in, you get division by 0, which is not allowed. Well, you also have to be cautious of that with this trig stuff, okay? Well, not up until now. This is the first example like this. Even though theta could be, 90 degrees and 270 degrees, the cosine of theta is 0. So if you go back to your original equation, that would get you 0, right? 3 times 0 equals, this will just be negative 0. I don't know what the tangent of theta is yet, so I'm going to leave that blank for now, plus 2 times 0. So no division of 0 going on, at first, but the issue is this tangent of theta. Let's go ahead and talk about the tangent of these angles. What is the tangent of 90 degrees? Tangent is slope, or also y over x. So at 90 degrees, my lovely unit circle here, the coordinate here is 0, 1. Well, if I do y over x, I get 1 over 0, which is undefined. And at 270, I get the same thing because it's just a negative 1. So even though that the cosine of theta is equal to 0 is like a valid choice for cosine, unfortunately, it's not a valid choice for the tangent value in the original equation. Okay, tangent of theta is undefined, or tangent in this case of 90 is undefined because it gives you division by 0 in the actual calculation of the value. So even though it looks like these two angles could be part of your answers, they cannot be. Okay, then you will proceed with algebra for the other part. 1 plus tangent theta is equal to 0. Well, if I go ahead and subtract 1 from both sides, I end up with tangent of theta is equal to -1, which we've done before, I think, earlier in this video. I'm looking for where is there a slope of -1 or a y over x value of -1. Again, I have negative slopes in the second and fourth quadrant because I have one value that's negative and one that's positive. So when I divide them, it's going to stay negative. And you should end up getting theta is equal to 135 degrees and 315 degrees. And those are the only two possible answers because the other two did not work. They were undefined. So recap of tangent particularly is the one that will typically give issues. Horizontal lines, that's where tangent is equal to 0, a 0 slope. I was once told like the difference, you can drive a car on something with 0 slope. South Texas has 0 slope on the roads. And you can drive it on other increasing and decreasing slopes. However, the tangent of theta on a vertical line is undefined. You cannot drive a car up and down an undefined slope. So hopefully that helps you be wary of getting those solutions that aren't really solutions.